Hello everyone, in this video we are going to see the concept of self-referential structures. We all know that structure is a collection of various data type. That means a structure can have an int data, a char data, a float data, or a mixture of so many types of data as the user wishes to define his data. That is the convenient that the programming is given the user to define his own data structure. So now here, coming to the definition of data structure, what is the definition is, among the data inside the structure, the data can again point to the structure itself. That is called as a self-referential structure. Now let us see with this simple syntax what is the self-referential structure is. You can see struct space node. So node is the name of the structure and the open braces starts and we have a data called data 1, which is int data 1 is the data here, and then char is the data 2. So there are two collection of two data type, int data 1 and char data 2. So two different data types. Now we can see the third line, struct node pointer link. So this is the point where we are using the self-referential structure. So what does it mean? Here the structure is containing one more structure, and that is again it is referring to the same node itself. That is the same structure itself. That is called self-referential structure. It is like a recursive reference, repeatedly referring its own structure. That is called as a self-referential structure. And then that's all. So struct node, the pointer is used to make the connection between the one node to the next node. So that is the reference, and then link is the name of the data we are using. So three datas here, data 1, data 2 and link. Data 1, data 2 are common primary data, which is int and char, and here data 3 is the link, which is following the node. And what is node? Node is the structure. Okay, so that's why it's using the pointer variable. So struct node pointer link means link is the part of the structure which is a data, that is a pointer which points the same structure itself, which is the node, which is its inside. Okay, now you have to close the brace and we have to terminate by a semicolon, and as usual we use in the main program into main, then struct node ob. So ob is the name of the structure. Okay, this is how the syntax of the self-referential structure looks like. Now let us see what is then application of this self-referential structures. The self-referential structures are used to create complex data structures like linked list, stacks, queues, trees and graphs, etc. So normally these are the complex data structures which is built as a combination of basic data types. That means a linked list will have a collection of nodes. So one node will have a data and the pointer to the next node. Likewise, the nodes are connected by a linked fashion. For these type of linking, the self-referential structures are very useful. So likewise, we have different data types like stacks, queues, trees and so on. So the basic application of this self-referential structure is they are used to build the complex data structures. Now let us see the types of self-referential structures. There are two types. One is with the structure with the single link and another is the multiple links. What is the single link is, as we've seen in the previous syntax, there is only one link which connects to the next consecutive data block. That is the single link. And there is also another way we can connect this multiple blocks using the self-referential structures using two-way communication. That means we can connect either the previous node and also to the other node, back node. Okay, so that is done by the multiple links. Here, that is, we can use the two links over here. Now see the syntax of this double link, structure node. So that is the definition. Struct is the keyword, node is the name of the structure, and then open the brace, int data. So data is one data type which is a simple preliminary data type int, and then you can see there are two definitions here. Struct node pointer previous link, then struct node pointer next link. That means one here we are having two referential nodes. One is the node which points to the next link, and another is the node which points to the previous link. So we are having the double way connection from this structure. So this is also self-referential structure, but the connection is made in both the ways to the previous and the forthcoming nodes. Now if you see the diagram, you'll be able to easily understand how this link looks like. Now see the example of this. This is the self-referential structure with a single link. You can see this is the data OB1 is one structure component which is linked to the next component, and this goes on and on. Then X symbol as it's the end node. When you say X is the end, means there is no pointer, means that's all, the reference is over. That means the continuity of the data structure is over. So that is done by the into mark. Now you see the next example with the double link, where we are having the link in the forward and the backward direction. You can see the first node is having the X as the value, which means it is an head node. That means before that there is no node. Likewise, the third is having an X in the block, which means this is the tail node. That means no other nodes are further. So only 3 nodes are in this structure: node 1, node 2 and node 3. So the node 1, 2, 3 are connected both forward and backward. So this is possible only through the referential data structure, which is like an self-referential data structure using the double link. So this is the application of how this self-referential structure is used. And same way, the self-referential unions also can be used. So this is also of the same way. The unions can be self-referenced both the way using the multiple and the single link. And this is the concept of this self-referential data structure, which is one of the user-defined data structure. Thanks for watching.